The second question is to determine the vector and the parametric equations of the plane that passes through the points q, q coordinate -4, 0, 1, 1, r 0, -1, 0, and s 0, 0, 3. And the part B is to determine if the point P coordinate 1, -3, 8 is a point on this plane. So in order to find the vector and the parametric equations of this plane, we find the two direction vectors, which is QR and QS. So QR is equal to R minus Q. So we use the coordinates which is provided in the equation, in the question, and we do x2 minus x1. So it is equal to x2 minus x1. So 0 minus -4. 0 minus -4, comma -1 minus 0, 0 minus -1, which is equal to -4, -1, -1. We do the same for the QS, which would be s minus q. So the coordinates given in the question, we use x2 minus x1 again, which will be 0 minus -4, 0 minus 0, and 3 minus 1, which is 4, 0, 2. And next we find the vector equation, which is x, y, z. So there's a small formula, r with the coordinates plus t with the coordinates plus s with the coordinates. So this coordinates is the coordinates that's given in the question, which is for q. So the q coordinates go here, plus t, this coordinates that we just solved for, -4, -1, -1, plus s into s coordinate of 4, 0, 2. That would be the vector equation. And next we find the parametric equation, which would be x, y, z, which we find the x values, the y values, and the z values as in the equation. So it will be r plus t plus s. So as per the coordinates that we found in the vector the vector equation, we use those. So in order to find x, we take the x values of all three. So -4 plus -4t plus 4s. That is what we got. Same for y, which would be 0 plus -1t plus 0s, which would be y is equal to -t because there's two zeros. And then z, we take 1 plus -1 plus 2s. That is what we found. And then next we find the normal vector. The normal vector would be equal to the qr into qs. And we are going to multiply these together. So we're going to use the few new variables j, k, and l. So a tip, which strategy to do this is a2 b3 minus a3 b2. We have to use the vector equation for this. So a2 b3, so we take the -1 into 2 minus -1 into 0 minus k. That was for j, and k would be a3 b1. So it would be 2 into 4, 2 into -4, minus -1 into 4, -1 into 4, and 2 into -4. And next would be L. L would be A1 B2, which would be 4 into B2 0 minus 0 into -4. And when we solve for that normal vector, it would be j of -2 minus k 12 plus L4. So we get n as, so we remove the variables, we get -2, -12, 4. And this next we solve for the scalar equation, which is ax plus by plus cs plus d. And one thing is, in the normal vector equation that we've just solved, the coordinates, we can divide it by 2 because it's all divisible by 2. So using this, we divide it and we get -1. 2 divided by -2, and we divide this by 2, so it will be -6 comma +2. So we put these coordinates into the equation. So we do -1x minus 6y plus 2z plus d is equal to 0. Then we use the q from the question, the q coordinates, substitute q, -4, 0, 1, and that was given in the question. We put it into the equation. So we -1 into 4 minus 6 into 0 plus 2 into 1, 2 into 1, plus d is equal to 0. And then you equate for d, and you get the value for d, which is -6, and then you put it back into the equation, which will be -x minus -6y plus 2z minus 6 is equal to 0. And now the next question would be to determine whether the point P, which is +1, +1, -3, +8, if this point is on the plane. So we use the left side to check if the point is on the plane by substituting the coordinate that we found that we have in the question, which is P. We put these coordinates into the equation by substituting them for x, y, and z. So left side is equal to -1, the 1, minus 6 into -3 plus 2 into 8 minus 6, and then we get left side as 27. But the issue is that since the left side is not, it's supposed to be equal to 0 in order for it to be